Happy Wednesday, everyone. Welcome to our Water Wednesday, new residence guide to Florida's environment. So I see people still trickling in. So just for the time we are waiting, if you can put it in the chat box, tell us, since it's a new residence webinar, I'm really curious, how long have you lived in Florida? Oh, if you are not in Florida, please tell us, how did you find this webinar? All right, I know typing takes a little bit of time. And I will just do a quick intro as you are typing and people are trickling in. So if this is the first time you join Water Wednesday, so what is Water Wednesday? So we started Water Wednesday back in 2020. So once we started that, it was a weekly Facebook live session. So we did it very short, every like 10 to 20 minutes and cover a wide range of topics. Could be in the backyard showing you how to install a rain sensor, or it's how to build a rain garden, and some can be how to build your own hydroponics. And we've been doing this online Water Wednesday since 2020, but the structure has changed, especially in 2023 and 2024. We brought a virtual Water Wednesday in person and did more hands-on demonstrations in Lake County Discovery Garden. So if you haven't been to Lake County, it's in Central Florida, and they have beautiful gardens. And in 2026, which brings us to this year, so we did a little bit shifting of the focus. Now this year's Water Wednesday really focus on new residents. Our goal is to help new residents understand essential environmental topics during their first year in the state. So with that, let's have a quick look, see where people are from, or how long our attendees have been in Florida. We have 10 years. We have native Floridian. Welcome. 26 years. That's awesome. Oh, we have another native Floridians. Last 3 years. Oh, we have people just move. So you can see it's like quite a big wide range of here. So just want to showing you some topics we lined up for this year. So we started from the whole weather and the seasons, move to water, to gardening for beginners. And this month, we focus on stormwater, which we'll talk a lot more later. And the next month, it's hurricane preparedness. Then it's understanding Florida's home, how to water Florida lawns, how to live with wildlife and the pests in Florida. And then some septic and sewer essentials in Florida. Will end our webinar series with Florida's natural resources and how we can enjoy them responsibly. So how Water Wednesday works. So it's a monthly live Zoom webinar, and we provide research-based information from IFAS extension, and all the participants can have live Q&A with our presenters, and we have interactive quiz during the session, which I will mention in the next slide. And we have our recordings and a recap blog posted after each webinar, and it's all posted on our website. And later I will drop the link of our Water Wednesday website. So I think since we already used the Q&A, I think you all figure out, we already used the chat. You already figured out how to use the chat. Just letting you know, once we start the webinar, we'll disable the chat and we'll funnel all the questions to Q&A. So in this way, once we finish the presentation, it's easier to address your questions. And we'll have some interactive quiz pop up during the webinar session. So just a little bit of incentives here. If you complete all the quiz questions, regardless correct or wrong, and also finish the exit survey, and that survey just really help us to understand how we are doing for this webinar. Nothing to reflect like your knowledge, just really evaluate this webinar format, and our presenters help us better plan for our next webinar series. And if you finish all these the quiz and the survey, you will get a door prize. It's a home water testing kit worth about $200. And I believe all these samples will be sent to a certified lab to test it. And inside there's a return label, a prepaid shipping label. And the door prize winners will be contacted directly. We'll do the drawing, and I will contact the winner directly and send the testing kit to the winner. So with that, let's start today's topic. And today's topic is Stormwater 101, understanding drainage, ponds, and how Florida manages rainwater. And our speaker for today is Dr. Evan Bean. He is an associate professor and extension specialist in urban water resources engineering at the University of Florida. His research and extension programs focus on stormwater management, green stormwater infrastructure, and improving water conservation and irrigation efficiency through ecological engineering approaches. That sounds really interesting. So let's welcome Evan and looking forward to learn more about you. More
Thanks
about
so much,
stormwater.
Thanks so much, Elin. Let's see. I'm going to try and share my screen here. All right. Well, thank you all for joining today, and thank you, Elin, for the invitation to speak. I'm really interested. I really enjoy being able to tell people about stormwater. It's kind of one of those things that a lot of times it's out of sight and out of mind, but it's so important to our environment and to just the way things work in Florida. And it's a little bit different here in Florida than a lot of other places. But I'm going to start out really fundamental and talk fairly generally about the water cycle and sort of what happens to rainfall as we go from a natural, undeveloped landscape all the way up to an urban city. What is that shift? How does that affect our water balance? And these are just kind of generalizations, but conceptually, I'm trying to get across the shift that occurs. So when we have sort of a natural ground cover, there's no impervious area, no concrete, no asphalt. We have maybe about half of that water will essentially infiltrate into the ground and make its way and recharge into the groundwater. And then about maybe 40% of that will either get caught by leaves or kind of stay at the surface or be in the shallows, the near surface soil, and roots will take that back up and put that back into the atmosphere. We combine evaporation and transpiration. So maybe about 40% goes evapotranspiration. And so that only leaves about 10% of the rainfall that actually gets converted into runoff. And so only about, so 10% of your rainfall goes to runoff in that undeveloped condition. As we start to add impervious cover, so now we're looking at 10 to 20% impervious, think about, 1 acre lots, if you will. So you've got a rooftop and maybe you've got a driveway, but the rest is basically pervious in one way or the other. So now we're shifting that water balance. We're decreasing the infiltration slightly, we're decreasing the evapotranspiration slightly, and we're bumping up the runoff now from 10% to 20%. And now when we look at sort of your 30 to 50% impervious, think of like, your residential development, basically quarter-acre lots or smaller. Now we're shifting, we've got maybe 35% infiltration, 35% evapotranspiration, and we're up to about 30% runoff. And then in our ultra urbanized downtown kind of urban centers, we've got only about 15% of that rainwater infiltrates through cracks and limited pervious area. And then 30% evapotranspiration, which is really most likely to be evaporation from puddles. And then about 55% of that rainfall actually runs off. Now, if we take the 30 to 50% imperviousness, the residential neighborhood, and we compare that to natural ground cover, thinking 10% runoff to 30% runoff, that doesn't sound like much. There's only a difference of 20%, but it's actually 3 times as much rainfall or that's being converted to runoff by changing the landscape that way. So when we think about what happens to the rate of runoff and what happens to how that water leaves the landscape from a rainstorm, I want to kind of do a comparison of what it might look like under an undeveloped or natural area in an urbanized area. So here, the blue bars, these show sort of different increments of rainfall during a storm. So it kind of increases intensity and then tapers off. And several differences happen within these two storm events. First of all, when we have an urban area, we're increasing the amount of runoff. We showed that with the previous slide where we go from 10% in the undeveloped up to 30% or even 55%. We also have a higher peak runoff rate. So essentially meaning that the rate of runoff is much higher than it is under the undeveloped condition. And the time between the peak runoff, so this time between the peak rainfall and the peak of the runoff that results from that, is much shorter. And so it's this is where we get the term sort of a flash flood. So it's a flashier system, right? So we have more water that runs off, and the connections cause that water to move through much quicker. And historically, our approach to stormwater management has been to essentially get water off site as quickly as possible. And if you look at a lot of older cities and sort of the older downtown parts, you'll probably see some examples of this. You probably don't see many like ponds or open spaces. It's just kind of pipes and directed to the nearest like creek or waterway. And we've gotten pretty efficient at this. You'll see like scuppers on the side of buildings that basically route that root runoff directly down to the street. We've got stormwater inlets and grates, and then those go into stormwater pipes that discharge into kind of that nearby waterway. But there's also within that stormwater runoff, there are water quality issues that come from it. We can have fish kills. We can have erosion. This is a friend of mine that's about 6'4" in a channel that's about 20 feet deep by about 6 feet wide. But we also have excess flooding. So when we get off that water offsite as quickly as possible, that might be good for you. But if all that water is coming to you downstream, then you are the one that gets flooded out. That's not a good situation. And we also can have drivers for algal blooms here. When we think of stormwater runoff, it's not just the volume, though. It's the chemicals that it washes off the urban landscape. And a lot of the urban landscapes can be sources for these pollutants that we're trying to manage or want to eliminate. So our roadways can accumulate oils and chemicals from cars, sediments, and metals like brake dust. Parking lots can collect sediments and organic debris. There's actually atmospheric deposition of contaminants or nutrients that accumulate over time. Our landscape, our lawns, nitrogen and phosphorus can come from those, particularly if we're fertilizing inappropriately. And then our pets. This is not my pet, but essentially they are walking, barking point sources of nutrients and bacteria. And so if we don't pick up after them, that can enter into the environment and wash off as well. So let's start it off. Kind of give a trial to the quiz poll here. Becky, if you'll go ahead and start that first poll. All right. Give you a little bit of time, but the sooner we get everybody's responses in, the sooner we can continue on. Let's go ahead and get those answers in. All right, close this poll in about 5 seconds. So make sure you get in there. 4, 3, 2, 1. Let's go ahead and close that out. All right. And so the answers were Runoff is what increases most in urban areas compared to natural areas during a storm. And then the higher peak flow and quicker response is what often happens with runoff. So nice job, folks. Nice job. Okay. All right. Moving on to our next, to kind of keep moving on. So when we think about stormwater management, there's a few different ways that we've looked at trying to manage stormwater runoff. The biggest concern that we had originally with stormwater runoff, particularly with the getting water off site as quickly as possible, was the risk for flooding. We increase this imperviousness. We've got this additional water. When we have a rain event, what do we do with it? One of the big aspects of stormwater management is not is sorry. One of the biggest aspects of flooding is the rate that water flows off of an area or through a system. So if we can kind of reduce that flow rate, we can help to alleviate that flooding response. So with detention, that's sort of the approach here, where we essentially capture that additional runoff and slowly release it over time. So if we look at sort of what our pre-developed runoff is and our urban runoff without any management, we see that increase. But if we kind of identify this pre-developed peak as the allowable flow rate for stormwater to move through, and we can basically capture that water and extend it out at a lower flow rate over time, we can reduce the flooding and erosion, the peak, reduce that peak rate, and reduce the risk of flooding downstream. So when we look at the size storms that we are trying to manage for flooding and designing, we can't design for the 1,000-year storm event. Those happen so infrequently. They're so large. It's usually not feasible to design for those. What we are typically required to design for are storms within the duration of 24 to 72 hours. And typically looking at that kind of a duration with storms that are somewhere between 25-year return period and 100-year return period. So with the return period, that doesn't mean that one storm of that size will occur within 25 years for a 25-year storm event. It actually means that there's a 4% chance of that size storm event occurring in any year. And similar with the 100-year, it's a 1% chance of a 100-year storm happening every year. So that's how we can have 100-year events in multiple years that are not separated by 100 years. Okay. But if we look at sort of the size of these storm events for flooding that we're looking at somewhere between this 10 and 15 inches of rainfall as that design storm. So if we have a hurricane or a large storm event that exceeds 15 inches or 20 inches in many parts of the state, then that's going to have more water than our stormwater systems can manage. And it's going to overflow, and we're going to have extra flooding occur within our communities. Yeah, so I forgot to bring that up earlier. So yeah, we're looking at sort of that range, 8 to 14 inches. So stormwater ponds are one of the main ways that we have implemented to trying to manage the flooding and manage peak runoff rates. And if we look around Florida, we did this analysis a few years ago. There's about 76,000 ponds statewide, and that's probably a low estimate now, just because of the amount of development and the continued installation of stormwater ponds around the state. There's so many stormwater ponds that it's even taken up more area than industrial land uses, which is pretty surprising. So it's a pretty prevalent part of the urban landscape. So the orientation, or what we typically see within a lot of land development and a lot of projects around Florida, is that we have our urban area, and for this case, we're looking at our residential neighborhood. We've got rooftops that can then drain into the driveway and then flow into the street, which then flows into a storm drain inlet and into a stormwater pipe collection system that then goes into a stormwater pond for an area of this residential development. And this stormwater pond is intended or designed to address several things. Number one is flood control. So capturing that runoff volume and then slowly releasing it. So by doing that, it's also kind of reducing that peak rate. And then we also have water quality benefits. Now, one of the things that is unique about Florida compared to many other states is that anywhere else in the country, the pollutant of concern that causes the most problems is total suspended solids or sediments in the water. And oftentimes they have very fine clay soil that will make it very cloudy. And those areas oftentimes have a lot of steep topography, much steeper than what we have in Florida. And so they can actually get a lot of channel erosion. So streams will start to cut down and widen, and a lot of that sediment can kind of be moved from the stream channel. Not the case so much in Florida, other than maybe in the Panhandle and out to the western part, northwestern part of the state. Here, our biggest pollutant is actually nitrogen and phosphorus. And so those are our main pollutants of concern. And that's what our stormwater pond treatment is intended to address. So if we look at a map of land use around Florida, this is sort of central Florida, and the red shows urban areas, the green shows conservation, sort of the yellowish color is agriculture. And we look at a similar map of where watersheds are essentially impaired, which means that the water quality of the streams or lakes in that area are not meeting their intended thresholds for high quality waters. And then if we overlap them, we can kind of see that there's a lot of overlap between urban and those impaired water bodies. And what this means is that, number one, urbanization is a big driver of water quality impairment or poor water quality. One of the main things that so while stormwater runoff is one of the main contributors to water quality impairment, agriculture also contributes some to water quality impairment, as does septic systems. So urban is not necessarily the biggest driver, but it's one of the top causes for water quality impairment. And so it's important for us to address that. But what we see essentially is that stormwater runoff, urbanization, impairment, or the poor water quality tends to follow over time the urbanization of watersheds. Now, if we look at the distribution of rainfall events that happen, before we were talking about the flood events, and that's where you saw sort of the 8 to 14 inch rainfall amounts. Well, when we look at most rainfall events that happen during a given year, we're really looking at between 0 and 8 inches, as you see on the y-axis. And if we look at sort of the distribution, we see here that if we look at all events, we see about 85 to 90% of all events are an inch or less, an inch of rainfall or less. And if we only count sort of those events that are above a tenth of an inch, we've got 80% of those events are an inch or less. And what's interesting is that a lot of the nutrients in runoff, particularly nitrogen, is contributed by these smaller afternoon thunderstorms that occur on a regular basis, right? So it's really these smaller storm events that are driving the water quality rather than those larger 8 to 14 inch, hurricane storms that are driving it. And so, yeah, so 80 to 87% of days with less than an inch, 90% of days have rainfall that are less than an inch and a half. So we're really looking at, a very small amount of rainfall on a regular basis is kind of contributing a lot of our nutrients to stormwater. So next, I want to get into sort of the nuts and bolts of stormwater systems and talk about some of the different components so that when you're in your communities, you can be able to identify and see the the different elements of a stormwater system and better understand what's happening there. So we're going to break it down a few ways. The watershed is sort of the land that's developed, and that's where essentially runoff is generated, right? So then the water comes off of that landscape, and then it's collected into inlets. That's where basically water is directed into pipes or channels to convey it to another location. And that's where it's usually routed to a stormwater best management practice. And in Florida, many times this is going to be a stormwater pond of some type. And we'll talk about what those are and how they function here in a minute. But essentially, we have the flow path. We have rainfall in the watershed. That runoff then goes into the inlets through pipes and channels and into our stormwater BMP. So thinking first about watershed components, we have within our urban area, we have sort of the impervious areas on the left, which are our rooftops, our concrete, and our asphalt. These are the surfaces that essentially prevent water from infiltrating into the ground. And so that water, instead of infiltrating, has to go somewhere. That's our runoff. On the right, we have our pervious areas. So these might be forests or landscape beds or even lawns. And these are the areas that we can that can infiltrate rainfall, that can infiltrate runoff, and provide a function to us in that capacity. Within the urban landscape, you'll often see sort of this structure right along the sides of roads. You might have heard the term curb and gutter. I used to think that that was just the name of it, just one word, curb and gutter. But it's actually two distinct parts of the structure that's right along the roadway, right up against usually a pervious area. But essentially, you have the curb, which is the vertical part, and the gutter is the bottom part. Now, you're probably familiar with gutters along the side or rim of your house, and that's sort of the intent here, that is the place that routes and funnels water, right? And roads, you'll find, are typically going to be crowned, so they're highest in the middle, so that water drains away from the center and gets conveyed to the curb and gutters. And you can kind of see this on many of our roadways. So looking down a street, these are both on the campus of University of Florida. And essentially, when we have a rain event, that runoff flows to the edges so that the drive paths don't pond water. We don't have to drive through pools. We don't have hydroplaning. And then it collects along that curb and flows down the gutter into the storm drains. And you can see sort of an example here where the water is flowing down a street, down the gutter, and then flowing into an inlet. Now, looking at the inlets, these are essentially the openings into the stormwater collection conveyance system. Now, there's several different types of them. And this is essentially places where water transitions from the landscape into a structure that is intended to move it to a certain location. So the surface of the landscape will typically grade or slope to these inlet points. And this is usually going to be either a curb cut into a superficial inlet or a superficial structure, or you'll see a storm grate that water can basically flow down through. So these inlets you'll see sometimes come in different flavors, if you will. These are a few examples of curb inlets where the curb goes along and there's a break in it, and then the water flows down and into a storm pipe. If you notice in the left example, there is a lot of debris that's collected there, and that will essentially eventually cause problems if that material builds up and blocks the flow of water into it. So it's good to kind of make sure we're not putting a lot of leaves down into that, and particularly not putting grass clippings, because that can carry a lot of nutrients with it. But you can see with each of these scenarios, water basically flows or is directed to the inlet and then into a stormwater pipe that then goes, in these two cases on the right in the center, into a stormwater pond immediately adjacent to it. Inlets and grates, these are another common feature. You'll usually see these in adjacent to roadways or in parking lots. And this is sort of in low spots where stormwater runoff can basically drop vertically into a pond or into a pipe and drain. Part of the function of a storm grate is to create a smaller opening than a curb opening so that larger debris does not make its way into the storm drain system. Now, you do see a combination on the left of a curb inlet and a stormwater grate. That can also be a configuration that we see as well. But oftentimes you'll see these grates on their own level with a low spot in a low spot of the road or a parking lot. And you can see sort of where the flow rates or the flow lines go to with this site. Again, on the left, with that yellow curb, note the accumulation of debris there. If that continues to build up, that can cause issues with the stormwater system by not allowing water to flow through as quickly as it's supposed to. Okay. Curb inlets, these are kind of openings in the curb that basically try to connect impervious areas with the pervious area. And these are also areas where you can get accumulation of debris and cause it to back up and not function as well. But this is a really efficient way to make those adjacent pervious and landscape areas more functional so that that runoff can basically flow onto this landscape and infiltrate or soak into the ground rather than having to go into a stormwater pipe network or into stormwater ponds. Pavement drains, you'll find these in the middle of a roadway or a drive path. Essentially, they are a drop inlet into a stormwater pipe network. These are usually the low spot, and oftentimes it's going to be actually within a parking lot is where I see them mostly, because the sides are crowned to the sides are graded to the stormwater inlet. And then they basically allow that water to go into a pipe network that flows downstream. Usually see this in a parking lot rather than a roadway, because oftentimes with roadways, we're crowning the road so that we are sheeting the water away from the roadway itself rather than trying to collect it in the center. Another configuration that you might see that's similar to those parking lot drains or those parking drains are field or surface drains. These are basically in the middle of landscaped areas or kind of at the ground surface that allows runoff to flow into them. Again, you'll see that there are the screening function that's happening there, particularly in that upper center one. If debris is allowed to build up, that can again cause issues with water not being able to flow through as quickly as it's designed. Right. And so it's showing here just that water collects at the surface and then can be taken away by a pipe underneath. So now let's take a look at the stormwater conveyance elements, stormwater pipes. These are oftentimes out of sight, out of mind. So you most likely have not seen these very much, but there's some pretty common materials. So a lot of times we'll see corrugated pipes, corrugated plastic pipes, corrugated metal pipes, and concrete pipes. Those are the three most common types of material that we see in stormwater drainage. Ideally, we'd like to have smooth wall pipes rather than having ridges or corrugated. This actually helps water to move completely through and not get trapped behind those ridges. And when we see sort of manholes, these are the pipes that are for our storm inlet or a stormwater system and not the sewer system. So if you're ever curious about which manhole, what system the manhole is for, usually on the top, it'll either say sewer or storm. So you can take a look at storm if you want to, but I would not recommend opening a sewer. Culverts. Culverts are pipes, usually short sections of pipe that are intended to move water from one location to another underneath a roadway or crossing. And that's essentially all that a culvert is. So these can oftentimes fall into disrepair if they're not maintained. They can have accumulation of sediment downstream or upstream of them and get clogged. So maintaining them is important to having water flow through them. And these can also be sort of the stormwater, the inlet to a stormwater system. In this middle one, we've got water coming from the background to the foreground. And then here on the right, we've got water moving across here. That blue arrow is so small because this corrugated pipe has likely been driven over a time or two and been crimped. So that opening is now smaller and it can be a restriction to the flow. And so maintaining and making sure that those pipes are large enough is important. Sediment is also a big concern. Sediment can accumulate in culverts and clog them up. It's really important to keep that clear. But usually you will oftentimes have a swale that's leading into a culvert. Water drains from the landscape on either side and then accumulates and flows through under the pipe and into another cross pipe or other place downstream. A lot of times you can see swales along roadways. You may call these ditches from other places. I did growing up. But swales provide multiple functions. They not only do the conveyance and moving of water, so we have the roadway basically sheeting water down the slope into the swale and then downstream. So, and by as water moves downstream, that water is also allowed to infiltrate into the subsurface and get filtered if water is continuing downstream. So, it's providing some water quality benefits as well when you see that. Other ways that you might see swales, if there's an erosion issue, a lot of times you'll see larger stone or rock in the channel, and that's to essentially make the channel more stable so that it's not washing out or eroding that sediment. You notice this figure in the upper left-hand corner, water's coming in this pipe from the left, and then it has to make a 90-degree turn and go up and to the left. And that is essentially what's causing some erosion here. So you can see they've tried to stabilize that with the rock and in this middle picture as well. All right, let's take a break and have our next quiz question. Becky, if you can throw that third question up. Let's see if you remember from early on in the presentation. With stormwater management, a lot of the decisions that were made early on, that infrastructure is still in place and the effects of that remain today. So it's kind of one of these sins of the past that continue to emerge or present themselves as we look at issues that emerge with stormwater management in many of our older communities or older sites. Let's be sure to get our responses in so we can stay on time, stay on track. Okay, looks like we're going to go ahead and close that out. All right. Yep. The main goal was to essentially get water offsite as quickly as possible. And that's sort of why we have a lot of flooding in older areas, historic areas. Some of that can also be due to lack of maintenance of stormwater systems and lack of repair to them, as well as climate change and more intense storms and those stormwater pipes and stormwater systems not being designed for as intense of events that we are getting now. Okay. So when we talk about BMP, this is one of those terms or acronyms that is, is a part of stormwater management. And with stormwater management, there's probably 20 different acronyms, but I'm going to try to limit this to maybe just one, this BMP. And BMP stands for Best Management Practice. And so that essentially refers to any type of practice that is used to capture, treat, or maintain stormwater, or sorry, capture, treat, or retained stormwater runoff. And so the way that water enters in or runoff enters into these BMPs varies a little bit. There's a few different ways that we see it. So for example, here on the left, we can have the pipe coming in and water basically flowing directly into the bottom of this BMP. That sand there might be a little hard to see, but there's definitely some signs of erosion going on there. And so if we don't have a way to dissipate energy, we can have some instability there. These two photos on the center and the right show that. Sorry. Oops. All right. So with the one on the left, we have that water coming in. It can kind of erode out this area, and then water basically spreads out and dissipates that energy. If we need to reduce that energy more, or other ways that we can kind of control or dissipate some of that energy are through these blocks in these channels as water comes in. That can help to dissipate it. There's also a structure known as a forebay that will essentially create a pool at the inlet, and that can help to dissipate the energy as water comes directly into that BMP. Now, there's two different ways that BMPs can be configured with a stormwater pipe system. One is, well, there's always a capacity limit to a stormwater BMP, whether it's a pond or a tank or whatever. There's a maximum volume that once that's reached, that excess water needs to continue to be routed somewhere else, right? And so we can either have the BMP be online or offline. And so I want to kind of illustrate what the difference is here. So with online, we have water come in for small storms. Water comes in and then bleeds down fairly quickly. And we don't see a whole lot of change in the water volume of the pond in this case. For larger storms, though, that water comes in, fills up the pond, and then it overflows or bypasses that outlet structure. So essentially, all of the water that comes off of the landscape and into the stormwater conveyance system moves into and out of that pond. If it's offline, for small storm events, we basically have just direct flow directly in, and we don't really see much difference in that in the operation. But when we have a large event, we'll have a high flow come in, fill up that pond, but then instead of overflowing downstream, we actually backs up the water level, and then we have bypass where the extra stormwater bypasses that inlet and continues to flow downstream. So now not all of the runoff flows through that BMP. It's really just that first volume of storage that fills up the pond, and then the excess goes back down beyond it. And so when you're looking for BMP outlets, outlets are only going to be for BMPs that are online, right? Because with an offline system, it's going to back up through the inlet. There's no need for an outlet. But if you see structures like these are usually boxes that have a grate on top of them, and they may have sort of a metal rim, and that's known as a skimmer. These are essentially the structures that collect and allow water to leave the BMP or the pond when we have very high water levels. It's really important that these grates stay in place and are free of debris, because if there's accumulation of debris or vegetation or anything else that can block the flow of water, that can prevent water from leaving the pond and cause water levels to rise much higher than what the BMP is designed for. That can lead to upstream flooding or erosion and other issues. So it's really important for those. So when we talk about different types of ponds or different types of BMPs, I want to go over sort of the main ones real quick. The first one is what we call dry retention. And this is something you would be able to see this in areas that have very sandy soils and maybe even in the springs areas, but you've got very well drained soils where water can infiltrate into the ground very quickly. And so essentially that the main way that it functions is that water comes into the basin, it fills up and then overflows out of the through the overflow structure if water is fills up the basin, and then that would discharge. But then essentially that water would essentially soak into the ground. For the most part, you would lose a little bit to evaporation, but essentially it recovers its volume by infiltrating into the ground, and that also retains those pollutants. And so you'd see a lot of times these will look like a grassed area that is a depressed or a low lying sunken area. And so you'll see these in a lot of areas where, again, we have sandy soils, well drained soils. You're not going to usually see wetlands nearby. So keep that in mind. Underground exfiltration is another way that we can have basically taking stormwater from the surface and infiltrating it below. These are typically configured offline, and essentially what you have is the stormwater comes off of a parking lot that overlies the structure, goes into a stormwater inlet, and then underneath that parking lot, it will flow into these half pipes, these structures here. There's a lot of volume, a lot of space there. And so water flows into it and then basically seeps into the subsurface or into the ground in between storm events. You'll notice in the lower right hand and lower left hand corner, there's sort of stone on top of these half pipes, and that's to add structural support so they can support the weight of the parking or whatever is being used above it. But essentially, very similar to a septic drain field if you're familiar with how those function and are configured. So yeah, again, water comes in, fills up those voids, or fills up those half pipes, and then it infiltrates into the subsurface below. Groundwater mounding is something I want to touch on just briefly because it can explain why, for example, a dry retention or any other infiltrating practice may sometimes, for certain storms, you might have it recover completely very quickly, but for other storms it may stay ponded for a long period of time. And so here we have the groundwater down below and infiltrating practice at the surface, and when we have a storm event, it fills up and then that infiltrates into the ground. But then that water, that volume of water, essentially as it starts to infiltrate and it hits that groundwater, it can no longer infiltrate vertically. And so what happens is that water volume starts to spread out, right? And so this mound basically has to spread out for that water level below to continue to fall. And so it takes a long time for that to occur. And so if you have another storm event soon after one of these events, then that groundwater essentially mounds up underneath this infiltrating practice, and so it can interfere with its ability to recover the storage over time. Wet stormwater ponds, wet retention ponds are one of our most common types of stormwater BMP. Again, similar to dry retention, they basically retain a certain volume. So runoff comes in, fills up the pond from the normal water level up to a design level. If we have excess water, that will overflow through the outlet structure and downstream. But then over time, it will essentially infiltrate laterally, and we will have evapotranspiration, right? Because oftentimes what's happening here is that we are intersecting the groundwater, the water table that is perching that water to maintain water in these ponds permanently. Detention ponds are actually not intended to remove volume. They are essentially just for controlling the flow rate and really for flood control, basically reducing that peak runoff rate. And the way that these work, whether it's dry detention or wet detention, is kind of similar. You have water come in to the pipe, it fills up, it overflows, and then basically all of that water bleeds back down, and you have the same amount of water that leaves the pond as came into it. With wet detention, you have water comes in, it fills up above the permanent pool, and then that water will overflow, and then it will slowly bleed down afterwards and discharge downstream. One of the main things is that we don't have very much benefit from water quality with detention ponds, because none of that water is intended to stay, or that volume of water is not meant to stay. But you'll see different configurations of stormwater ponds around Florida. You can see different inlets and outlet structures. They make up quite a bit of our landscape. And so, Becky, if you could throw up those last two quiz questions. Thank you. Right. Let's go ahead and get those answers in. All right. Going to be closing here in about 5 seconds. So get your answers in. 4, 3, 2, 1. All right. Let's see how we did. Very good. Very good. Yes, nitrogen is a common pollutant urban stormwater. And the purpose of stormwater detention is to slowly release water to reduce that peak flow rate, because we're trying to minimize flooding. All right, we're on the home stretch. A couple more aspects. I wanted to kind of just touch on some green infrastructure that we do see in Florida that you might see. One of the more common ones is permeable pavements. Permeable pavements are a lot of times they look like they have the same function, we say, as conventional pavements like bricks or asphalt or concrete, but they allow water to drain through them. And essentially, you have a rainfall event, water drains through them, builds up, and then can slowly soak into the soil below, or it can have an underdrain that allows that water to drain out. One of the main things that I like about it is that you can have sort of your pavement and your stormwater management in one location. With the pavers, there's basically small cracks in between the pavers that allows water to drain through. With concrete and asphalt, the structure is similar to a Rice Krispie treat, in that you have large aggregates that are cemented together without these small finer particles that fill the voids in between those aggregates. And those interconnecting pore spaces allow water to drain through. And so if you ever see pavement that looks like a Rice Krispie treat, it's usually going to be a porous concrete or porous asphalt. So with bioretention, these can be online or offline, and these are oftentimes sort of smaller scale dry retention, but they usually have vegetation planted in them to look nice, to provide an aesthetic. And they commonly will have under drains to make sure they recover the volume within the practice before the next storm event. So this allows that water that drains through the surface into a stone layer below, and that slotted pipe will basically take that water downstream. And so usually within about 24 hours, it can be recovered. Bioswales are kind of a twist on bioretention. So swales are meant to convey water. And so this is intended to do the same. You're usually taking it from one place to another, but it forces a certain flow rate of water to go down through the engineered soil and into the stone layer, where there's an underdrain pipe that continues to, or basically routes that into the stormwater network and takes that downstream. If there's excess flow rate, then that can overtop that overflow structure and cause water to go overflow and downstream directly without being filtered. And if anything is flow rate exceeds the storage of the bioswale, then it can bypass. Sort of just another look at bioswales, just a cross section. So usually you have water that's coming in, and then that water will build up and then basically be forced to go down through different layers of soil or media to improve the water quality. The under drain will collect that water and send it into the drain downstream. If we get water level too high, it will basically overflow into that overflow structure. Stormwater vaults are another practice that not necessarily green infrastructure, but they are very common. And this is essentially a detention structure meant for volume and flow rate control. They do have some sediment removal, but essentially it's kind of like a big tank that's underground. And it looks a lot like the subsurface exfiltration, but this system on the right does not exfiltrate or doesn't allow water to drain. And so what happens is water fills up and then comes in very quickly and then slowly bleeds down out downstream, preventing the flooding from occurring. We can also have cisterns. That's sort of how these work. Cisterns work a little bit different. This is one that was installed actually here in Gainesville underneath a parking lot. And essentially, they were able to use this at a fire station. They bring in these large tanks, the runoff from the roof and the parking lot come into here, and then they can pump that out for irrigation around the landscape. So instead of it just bleeding down all the way to the bottom after the storm event, it holds that water and is utilized by the pumping and the irrigation to recover that storage. So if you found this talk kind of interesting, want to find out more about stormwater management and different practices, I want to point you to a few resources. One is our GSI photo library. This is sort of like a photo essay of different sites around the state where stormwater management innovative practices have been put in place. And there's information about those specific projects, even some interviews with people who designed them. So we worked with the Nature Conservancy to put this together. So I'd encourage you to do that. And then if you're interested in some other resources as well, many of the resources that I've produced as part of the extension work that I do are located here at this website, basically Green Stormwater Infrastructure at Florida DEP. And there's a lot of different resources. Some are technical, some are non-technical, but you can get a lot of good information here about stormwater management in Florida. And with that, I'd be happy to take any questions that you have.
Thank you so much, Evan. This is really informative, and I love all these graphics you shared. That's awesome. Uh,
Yeah,
that's nice. And we do have one question here. Uh,
sure.
it's about the paver, the permeable
Okay,
pavers you mentioned. What about the
right.
people who seal them?
So we may be talking about two different things. And John, correct me if I'm wrong, but I see cracks in pavement where they're non-linear. They're kind of like squiggly marks that people kind of come over and put a little asphalt strip over that to kind of seal the pavement. And that pavement itself is usually not intended. That's not meant to be pervious or allow water to drain through it. So in that case, that's sealing that crack is kind of just part of maintaining that impervious surface. With the pavers, where it has voids and cracks between it, and porous concrete or porous asphalt, actually, there is some risk of people not being informed about the function of the pavement and then paving over it, or putting you may have seen like a sealer going over an asphalt parking lot and just sealing the pavement. That's where, number one, there needs to be communication with the the owner and the property owner that what their system is intended to do. And a lot of times that needs to take place at when a property changes hands, because it's usually that information is not conveyed to the next property owner. They don't understand that this pavement is different than typical pavement and allows water to drain through it. Okay.
There's a lot of questions.
Ooh. Okay. So why not landscape with artificial grass or nitrogen and phosphorus runoff? Well, so a couple of reasons. Artificial grass, there are several things to consider. Number one, it depends on what you're using that space for. Um, that area, if it's a sports area, can get very hot. Research has kind of shown that there's a kind of a heat absorption effect, and so there's aspects there. What we've seen with artificial turf installation is that if it's installed properly, which is how a lot of professional fields are installed, and they're basically installed and they rely on drainage to be very good. If it's installed that way, it can function pretty well. However, oftentimes what we see is that the installation, it creates basically an impervious layer below that artificial turf, and you basically have a concrete down below. It's basically crushed fines that go and it compacts, and water does not infiltrate there. Furthermore, you're always going to have sort of some type of, you're going to have to control weeds. Weeds are going to find a way to come up through that. So you have to maintain that as well. So just something to consider. It's something that I think each homeowner has to consider, and it might be all right for smaller areas. But for, yeah, let's see, to try and get to some of these other questions. So downstream, most of the illustrations show downstream for the eventual flow of water. Many jurisdictions require all stormwater runoff to be retained on site. There's no downflow in the design. Please comment on how this issue is. So yeah, when you have all stormwater being retained on site, that's where a lot of these green stormwater infrastructure practices can occur. Or, if it's in a residential development, you'll see it that it is a dry retention or infiltration basin, or a wet retention pond that is within the bounds of the community. So that is still considered on site. So yeah, with a lot of the green infrastructure practices that try to infiltrate stormwater on site, that's how that's being met. But there are situations where the conditions don't allow for infiltration, high water tables, um, poor soils that don't allow for infiltration. So those things have to be addressed, and so you then do have downflow. There's actually some newer rules that are going to be coming into play in the next year or so, where developers or people who are developing a piece of property, instead of treating stormwater on site, can pay for off-site treatment or buy those credits from it. The new developments become more environmentally friendly. They look sterile with no vegetation. Yeah, one of the things that in IFAS that we try to, I'm going to defer actually to Becky. Becky, do you want to answer that? Is that what I'm seeing?
No, no, you're fine.
Okay, sorry.
That that's
We've
just to
got
let you
some,
know we're
you
answering it.
got it. Okay. Sorry about that. Yeah, with retention ponds, it's really important actually to have vegetation around the rim. And I didn't have enough time to kind of get into what's called the littoral zone. And that's where vegetation is kind of coming up the water, up out of the water around the rim of a retention pond. And that vegetation actually plays a really important part in maintaining the integrity of the bank, because the wave energy that occurs when storms come through and winds blow, that vegetation will absorb that energy rather than eroding and washing out the bottom of that bank. And then we also recommend having a 10-foot buffer around the edge of stormwater ponds to help to filter that runoff that's coming off the landscape directly into the stormwater pond. We actually have a program that I think is close to being released, an online training that's called Florida Friendly Ponds, that really goes over a lot of the management of stormwater ponds and how to do it holistically. Instead of just treating the symptom, it's looking at how do we kind of manage a pond like a fish tank, right? You manage that holistically, right? You manage the cycles of nutrients in a fish tank. You're not just saying, well, I don't like the algae, I'm just going to clean the glass every day, right? You're not doing that. You're putting in an algae eater. You're putting in plants that are taking up nutrients. You're replacing the filter, those kind of things. I'll be honest, Anita, I'm not sure that I mean, I think there are a lot of different considerations that go into concrete and asphalt. They're actually considered so so yeah, asphalt is considered a flexible pavement system, whereas concrete is a rigid pavement system. It is much more intensive to put in a concrete roadway than it is to put in an asphalt roadway. Um, Essentially, concrete, you've got to have the base, you've got to pour a thick slab, and it usually will last longer um, than the asphalt pavement. And that's why you'll see it on a lot of interstates. Whenever they pave it, they'll just go ahead and put in cement in many cases where they really can't sacrifice shutting down the pavement for to do this maintenance. But asphalt kind of breaks down a little bit quicker, and so for uh, lower traffic roads, where they can essentially they can shut down a lane and kind of do that maintenance on a regular basis, or they may not have the upfront cost if it's a local community. That's why they typically stick with asphalt.
Thank you so much, Evan. I know it's a lot of
Absolutely,
questions,
absolutely
and
love these questions.
they are great questions. Um, yeah, and I appreciate everyone stay on. I know it's 6 minutes after 3, but we still have people stay on for this great information. Uh, and
Yeah,
really appreciate having you share your wisdom with us, share your experience with us. So thank you
happy
again.
to.
And just a quick announcement for next week, or next month, not next week. I think I mentioned next month, which will be July 17th, our talk is hurricane preparedness. So especially useful for these people who are new to Florida. We'll discuss these essentials, like what is good tips and practices prepare hurricane in Florida, and also good refresher for our native Floridians and long-term residents. All right. Thank you again, Evan. And thank you
Absolutely.
everyone for joining us. Hope to see you next Water Wednesday. So bye now.